Okay, so today, our last day of new material. Okay, tomorrow we might clean up some stuff from the notes that I don't do today in class, but that's about it. Um, the objective to write the equation of a circle and define the center of the and radius of the circle. And you'll be able to do that today. Our general form of the circle is right here, right going across there. X minus h quantity squared plus y minus k quantity squared equals r. Now, every year I do this, people are like, what the heck is this hk thing, Bloom? Whenever I work with conics or anything with other values of x and y, we represent them. Those are the ones that you're going to plug in h and k. And every year students go, Bloom, which one goes with x, h or k? And I go, well, which one's first in the alphabet? And they go A, B, C, D, F, G. I'm not there yet. You know, it's like you're almost there. H. Oh, H. H is first. I, J. K is next. Now I continue doing the alphabet, and then they finish off, and it's X, Y, Z. X is first, and Y is second. So H goes with X, K goes with Y. And if you forget, sing the alphabet to yourself. You don't have to do it out loud. You don't have to share it that way. Okay? So H is your X value, K is your Y value, and this is your center. Okay? When we do this, and when we read it the opposite. We have to have negative signs in between the X and the H and the Y and the K. So this is the standard equation of a circle. XY is actually a point on the circle. HK, it's its center. Okay? Now, I always have students, once they plug it in, am I done? I want it in that form. So let's get it going so you guys see that you're done. But before we get there, I want you to make sure that you recognize distance formulas, relationship to the circle equation. So here we go. Here's why it works, what we just talked about, that x minus h quantity squared plus y minus k quantity squared equal r squared. Okay. The distance formula to find an equation of a circle with center hk and the radius r, which proves theorem 1216. Let xy be at any point on the circle, then the radius r is the distance from hk to xy. So we're talking about a distance formula here. Okay, so we got this going on. And notice how we're going to let d evolve to r. Okay, it's almost like those pirates, you know, they started saying R and it's R, Captain. It's like, how far do we have to go more, Captain? Because this distance is R. Okay, so distance is R from the center to the edge of the circle. Now, I'm going to substitute things here. So I'm going to substitute for xy for x sub 2, y sub 2. I'm going to substitute hk for x sub 1, y sub 1 for us to get to this equation of a circle. But now, keep in mind, I got to square both sides to get rid of that square root, and that's what I do to finish out my problem. Not only is this kind of reminding me of distance formula, but it's also, this is how we develop the idea of the equation of a circle. I think it's cool. Some people are like, dumb. Okay, so now, please keep in mind today, it's all about properties. It's always about putting things in the right spot. Okay. So now, given the center and radius of a circle, plop in the h and k. Remember, center is h and k. Plop in h and k and plop in r. And remember, square your r value. And people are like, what do you mean? It would be 7 squared. It would therefore be 49. So there we go. We got h and k plopped in, and students always ask, boom, can I leave it at x minus 0 quantity squared plus y minus 0 quantity squared equal 49? And I go, no. You want x squared plus y squared equal 49 because 0, 0 is represented by x minus 0 is just x, and y minus 0 is just y, and that's what we're going to do. So now it's your turn. You guys have the equations. Plug them in. Get them done. Plug them in, get them done. Plug them in, get them done. Let's get her going. So now, look left, look right, check out your people around you, see what they got for an answer with those. Because it's just plug them in, get them done. Check with somebody else. We're doing it right here.
Okay.
Right there. So we got plug them in, get them done. Are there any questions on those two? Thank you. Any questions? Now, here's the deal. Speed round. You know what we're doing. Go get it done. Do it again. Go, 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 go. Remember, the first time you're not as fast as the second time, and you're not as fast as you are the third time. And now with these three, we should be zooming. Be careful about how you plug things in. On the test, students look at this and go, oh, this is a breeze. I'm looking forward to it. Remember, it's about what you know and how careful you are at knowing it. So please make sure you're careful. Are you okay with -3 and +4 and then 5? It's plugged in like that. -3, x plus 3, +4, y minus 4, 5 is squared, it's 25. I'm doing the same thing. -3, x plus 3, -5, y plus 5. But now, square root of 5 squared is 5. Check that out. I'm still doing the same thing. Okay? Any questions? Do the last one. Get her done. How you doing? We doing okay? Now, everybody's starting to go, well, this is circles. This is awesome, right? So now we took a center and a radius and we wrote the equation. Yes, sir. Anthony, what do you have for a question? Oh, okay. I thought you had a question there. Now, on this problem, I'm giving you information to find pieces of the circle. We need radius and we need center. We are given the center in a point on the circle. Okay, yes, sir. Do I leave it in square root form? If it's a perfect square, find what the square root is. Like if it's the square root of 25, it's 5. If it's square root of 49, it's 7. But if it's the square root of 26, leave it that way. Don't mix it as we go through. Okay? So when we're talking about this particular one, I've got my distance form. You know, I kind of morphed it. I made it R is equal to something. And now I've got X and H. I want to be honest with y'all. The order doesn't matter here because we're squaring them. Okay? But I got to find the difference between the X's and the difference of the Y's, and I'm squaring them. So I pop them in. Okay? And now I evaluate. So I got 2 minus 1 is 1 squared, 1. 2 plus 3 is 5 squared, it's 26 as I go through. That's your example of square root of 26. There isn't an exact, I'm not going to simplify it any further. I just want that because it's easier for us to take this radius and plug it into our formula. And we're done. X minus y, 1 squared plus y plus 3 squared equals 26. Okay, and that's it. Now, problem B is the same as problem 1. If you'd like, you can practice it. But I would like you to go on and do C all by your lonesome because it's the same method. Go. So you'll use the same stuff. Skip this one and do this one. Yes, sir.
Instead of putting the square root right there, right, could you just square it?
You could go through, but no, be careful because I'm going to be asking you to find the distance, and I don't want you to be going a shortcut and think, well, that's what I do. Okay, so you got to make sure you cognitively are aware of what you're being asked to find. Because part of this is me practicing distance formula today. because the distance between 2 points is our radius today. But when I have it on the test, and I will have it on the test, whether it be chapter 12 or the final, you need to know the distance between 2 points given is the same idea. We're just finding radius type thing, the distance. Notice the numbers I'm plopping in. Notice the numbers. At this point, we should be pretty comfortable with this, okay, as we're stepping through these. Yes, Mr. Item. Yep, the radius should always be positive. You're correct, because that's going to be a distance between those 2 points, and that's the positive distance, okay? So as we go on through this, we get the square root of 25, which everybody goes, well, that's 5 Bloom. Now, danger, Will Robinson. It's like all of a sudden it's a Lost in Space episode, and the robot's going, danger, Will Robinson, danger, danger. When you're an algebra student and you get to something you're done with, you got R is equal to 5. Woo-hoo, I'm done. In geometry, and this is the same thing I've been talking about the whole year, reread your question. Make sure that is actually what you're supposed to find. So I reread my question and say, hey, you're supposed to find the radius of this of the circle when we give you a center and a point on the circle. So we got that. But then we're supposed to write the equation for the circle. Oops. I got to pop the stuff in and write the equation. Please be advised, HK is the center. I do not want you to put the point on the circle as the center, and that's a real common mistake people will make. The center is 0, 0, so it should be x squared, y squared, 25. Are you okay with that? Now, we're going to do letter D. Read the question in D, and then read the question that we started with. They're phrased a little differently, but I'm asking you to do the same thing. And the reason why I did this is I always have students, well, you didn't ask it the way you did. It's like, guys, I can ask it a little differently each time. You have to like recognize based on the wording that that's what I'm asking you to do. So what is the standard equation of the circle with center 4, 3 that passes through the point negative 1, 1? Same method. Go. Get her done. Get her done, get her done, get her done. Thanks, dear. Yeah, Nate, what do you got? So I'm going to find the distance between these 2 points. That'll be my radius. After I find that, there's the way we've been doing this. I then plug it into my circle equation. So that's all I'm doing. But remember, grab the center, not just the point on the circle. Okay? And that's the thing I want to emphasize on this. So I've got this going on. Okay? And then I find the distance between 4, 3 and negative 1, 1. And so I'm here at the square root of 29. After I do that, I'm just going to plug it back into my circle equation information. And when I do that, I got to recognize what my center is. Let me get that down a little bit so I can point to things. My center is right here, and I kind of outlined that as I went through. I have a tendency to highlight them as I read stuff. So that way, when I look up to grab my center, I've already had it highlighted as I'm going through. I don't want to grab that one that is just a point on the circle. I need to grab the center. It's very specific because HK is the center, and that's how we're getting it done. Questions? Doing okay? Golden? Gonna wait here for a sec. We'll pause. Now, we've been presented equations of circles. We've written in the equation of circles, provided, you were provided the center and the radius. We found the radius when we were given the center and a point on the circle. Now I'm going to ask you to pull out the center and the radius from an equation instead of putting it in. And I'm going to ask you to graph it, okay, as we do this. So that's the next step. So I have my center and my radius defined. Go ahead and find the center and radius in A, B, and C. Find the center and radius in all three of those, please. Okay, if you're having difficulty, I'm walking around, just let me know. Okay, if you're doing all right, fantastic. You can look left and right. You don't have to just go from me to me for the results of stuff. You can talk to other people about, hey, how do you get the center? How do you get the radius on those three? But we're going to practice these three together. And after we do that, I'm going to have you do the other three. Okay, so make sure you're careful. Make sure you're just paying attention to what you're doing, because it's kind of important for us to get that done. Now, the center is 0, 0. My radius is 5. Are you okay with what I've got there? Any questions on how I found that it was 0, 0? Any questions on how it was 5? And B, the center is 2, 0, and my radius is 3, because 3 squared is 9. Any questions about that? Yes, sir. How did I get the 5? Square root of 25. Okay. Any questions? Yes, sir. How do I get the 2, 0? I look at that value and I determine what number will make that value 0. X being 2. So that's why I know I've got a 2 there for my center. What value will make y 0? Well, 0, because it's all by itself. Okay? So now I've got those going. Here, same idea. I got 1, 3, and I got 4. Maybe, as I go through. Are there any questions how I read the center and read the radius? Reading center, reading radius. Now, I'm going to graph. First step on graphing is go to your center, 0, 0. Next step on graphing, 5 out. 1, 2, 3, 4, 5. That's my radius. And go north, south, east, west. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now I get to draw my circle. It could be a squircle. It depends on your circle being a square or a circle. Okay. Every once in a while, mine look like I dropped it a few times and they're dented. Okay. They're not really circular. They're more squarish. But I want you to know that that's what we're trying to get to. That circular pattern. You start at the center. You use your radius out from the center. North, south, east, west. All 4 directions out. And then you make a circle. Do the same in B and C, please. Go to the center. Okay. Go out the radius. Make your circle. Go to the center. Go out the radius 4 different times. Make your circle. So in B, I go to the center, 2, 0. I go out 3. 4 different times. And I get my circle on, hopefully. Or not, because I got rid of it. There it is. Are you okay with what I did? The circle's a little off. Yeah, it's not coming up, it's frozen. Okay, are you all right? Yes, no, maybe? Go to 1, 3. Go to 1, 3. 4 out. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Draw my circle. And I'm done. Okay, now, how can I make this harder? Pay attention to the units on your graph. That is the #1 thing that SAT, ACT, MCA all do. to increase the difficulty of a problem. The units goes up by 2s or 3s or 4s. Pay attention to that. Do the same thing with C, D, and F. Same thing. Find the center, find the radius, graph the circle. Find the center, find the radius, graph the circle. Yes, sir.
Since this is like a -1 and -3.
It's 1, 3 is my center.
1, 3, but like for this one, would it be
-4, 6. -4, 6. It's a 3, really. Okay, are you okay with -4, 6? Good? I go to -4, goes up by 2, so be careful. Go up to 6. I go out north, south, east, west, and I draw my circle. Are there any questions? This is the fun part of this. You guys go ahead and finish the next 2. Pay attention to units. Units are key. Units are key. They're a big deal. Do the next 2. We'll see where things are going. That E comes off the grid. It's kind of like its cell phone got turned off because it went off the grid, right? Cell phone's off the grid. Turned off. Cell phone's down. Love it. It's off the grid. So I got -2 and down 6. I'm right here in my center, and I go down here, and I'm going around there. And that's where I'm getting it. Are you okay with this? Are there any questions on how I'm getting center, how I'm getting radius, how I'm graphing? Those are the big 3. Center, radius, and graphing, oh my. Center, radius, and graphing. Center, -1, 3. Radius, 7. Graphing, -1, 3, 7. Up here, I'm going around. I'm getting her done. How you all doing? Good? Good, good? Are there any follow-up questions? No? Okay. Now, I'm going to skip that one. Do problem B. And how am I going to have you do it? I want you to take the graph, pay attention to units, find the center, find the radius, write the equation. Okay, find the center, find the radius, write the equation from the graph provided in B here. Now you're going to do B and C on this. B and C. Find the center, find the radius, write the equation. Find the center, find the radius, write the equation. Remember, it's from the general standard position, standard form of your circle. Find the center, find the radius, write the equation. You okay? That was weird. Don't I have it in there? Should be right there. There it is. Let's get rid of that 6. Cut. Okay. Are you okay with center and radius? After I do that, I just pop it in the equation. X squared plus y plus 4 quantity squared plus it was equal to 36. And that's the dealio. Get C done and look left, look right. Compare your answer with a row partner. Do C, look left, look right. See what's going on. Is it going okay? How did I get 6? You ready? 2, 4, 6 goes up by 2s. You okay?
Yeah.
Okay, that's all I did. And remember, in order for me to graph the circle, I go north, south, east, west with my radius. And able to find radius, I check it north, south, east, west. Okay? And pay attention to our units. Make sure if you got a question, you ask me. Okay? What's the radius? Isn't it 4, so therefore it's 16? Is it 2? Oh, okay. All right, good. Good pickup on that. Okay, are you okay with radius is 2? Yes or no? Who said 4 because we've been doing sets of 2s, you know, going up by 2s? Okay, good. Good. You caught that, right? Okay, flipping back and forth between quadrant scale is a big deal. We got to make sure we're careful about that. Questions? Doing okay? All right, let's go on to the stuff on the bottom there. Now, before we get there, I want to talk about something. Let's look at B. Okay. Is this point on, inside, or outside the circle? Inside. Okay. Is this point on, inside, or outside the circle? On. Hey, people are like, hey, we can do this. This is awesome, Bloom. Is this point on, inside, or outside the circle? Okay, pretty obvious to see when we do it on a graph, right? And you're like rolling your eyes at me going, I cannot believe he decided that this was a good questioning methodology. But what I want you to know is that that's what we're going to answer in the next 2 problems. Except I'm not going to do it with a picture. I'm going to do it with you evaluating. And that evaluation comes out to be this. So check out how it evaluates. If it's in the circle, when you evaluate with that point, it is actually less than the radius itself. So it's less than the radius. When it's on the circle, it's equal to what the radius is. When it's outside, it's greater than what the radius is. So when I'm doing this, and remember this one is a circle at 0, 0. With a radius of 2, and I go around like this, and I got my little picture. So if I go to 0, if I go out to 0, that should be actually on my circle. What's it look like if I plug things in? 2 squared plus 0 squared. And I'm considering, hey, is it equal to, greater than, or less than? And it's actually equal to, so it's on circle. When I plug in 1, 2, 1 squared plus 2 squared, and I'm considering 4, I'm looking at this and I go, well, gee, you know, that's 5. That's outside the circle. And I go 1, 1, 2, 1, 2 is right there outside my circle. So this is outside the circle. And when I evaluate, oh boy, somebody can't just spell today at all. Circle. When I evaluate 2, 2, it's 2 squared. That's 2 squared. I'm wondering, is that bigger or less than or greater than 4? And it actually comes out to be 8, right? So it's greater, so it is also outside. I always have people think that that's inside in my last one. Okay, and we know what that looks like now, in, on, or outside. What I would like you to do is realize that was a circle at 0, 0. In this next one, I'm going to do the same thing, except the equation I'm going to use is connected to the equation of the circle we're evaluating. Actually, not equal to 9. I'm determining what goes in there. Is it the alligator eating something, or is it equal? Are you okay that I have to change and x is 2, y is 1? Now I evaluate, and I got 4 squared, which is 16, and I got negative 2 squared, which is 4, and now I got 20, which is much greater than 9, and what do I know? It's outside my circle. And people are like, no, so it's outside. Okay, you guys go ahead and do the other 2. Determine what they'll be. Que sera, sera. Whatever will be, will be. The future is ours to see. Que sera, sera. Remember, right now we're evaluating with a purpose. Okay, this evaluation with a purpose is a deal. So you know what it's like to determine if something's in, on, or outside a circle, given the equation and the point, and we're checking the point. And now, as an instructor making tests, I can change the test. I can have 3 different tests out there, same question. This is awesome. All I have to do is change one word. Is the point provided on the circle? Is the point provided in the circle? is the point provided outside the circle? Which one of them? Find the one and then put it in your answer. And it looks exactly the same because students don't pay attention to that one little word change. Be careful. Read the entire question because it's your test and it's going to be a different test from somebody else. It's fun that way. Okay. As we go through, we know this is 5 is less than 9, so it's inside. Here, as I go through, 9 is equal to 9, so it's on the circle. Questions about in, on, or outside the circle? Cool, we won't do the next two because I had plenty. Okay, we're not doing that. We're not going to do those. We are done for today. Okay, so what I want you to know is that's today's notes, and then the stuff that we know is going to be helpful for today's assignment. The 12-5 assignment that we've got going on here, we're good to go. Yes, you may. Now, the stuff that we've got going on is correcting 36 and 37, and then we'll probably get to those other ones tomorrow. We'll see how far we get, but I'm going to take attendance really fast. And notes overall. So hopefully, if you're at home, you had already talked to somebody about these answers because we're out of here, and have yourself a great day.